I'm Molly Ilbrock. I head communications and marketing here at ESMT Berlin, and it is my pleasure to welcome you today. It would have been our president, Jörg Rohlheu, but he is out of the country, so it landed to me. We were very, very excited to have Hal Varian here today on the open lecture, Competition and Data Economy in the Digital Age. So if you haven't been to ESMT before, I won't talk much. I could talk for hours and hours, but I will tell you, we were founded in 2002 by 25 German multinational companies. And we opened up this campus in 2006. And the room where you are here, you can tell, is not under historical preservation, but much of the building is. It is the former State Council building of the former GDR. And we are just a pretty, regular business school. We offer an MBA, Master's in Management, Executive Education, where we are top in Germany in executive education, and very international. For example, 90% of our MBA class is non-German. And as you might notice, I'm not German either, but some people think I am. No. So we inaugurated this series of open lectures in 2009, and since then we've had a great number of very renowned speakers, and I'm very glad that we have Professor Varian to add to this group today. He's going to discuss the digital economy, the value of data, and competition in the digital age. And I'm very much looking forward to hearing more about his experiences at one of the most innovative companies in the world, and to hear what you have in the question and answer session we're going to have. Hal Varian is the chief economist at Google. He started in Google in May 2002 as a consultant and has been involved in many aspects of the company, including auction design, econometric analysis, finance, corporate strategy, and public policy. He is professor emeritus at the University of California, Berkeley, and has taught at MIT, Stanford, Oxford, Michigan, and other universities around the world. In 2006, he received the Humboldt Prize from the Alexander von Humboldt Foundation. Hal Varian is perhaps best known as the author of two major economics textbooks, Intermediate Microeconomics and Microeconomic Analysis. These have been translated into 22 languages, and they are the pioneering work for many other textbooks as well. And I have to say, I'm not an economist. I sometimes play, just like I play a German, sometimes I play an economist here at the business school. And I did ask my husband, though, who took economics, and he's like, oh, yeah, I used that textbook. Just wanted to make sure that it seems to be the Bible of economics is the way I've heard it. I can go on and on. Professor Varian is also the author or co-author of a best-selling book, Information Rules, and this was, which I think is really, really cool, one of the 75 smartest books about strategy, according to Fortune magazine. So our lecture today will be moderated by Professor Catalina Stefanescu-Kunze. She's a professor of management science and the Deutsche Post DHL chair here at ESMT. She's also our dean of faculty. Before I hand over to Professor Varian, I would like to thank our media partners, Der Tagesspiegel and Harvard Business Manager. So, Professor Varian, welcome. The floor is yours.
Thank you very much for that kind introduction. I think the plan is I'm going to talk for about 20 minutes, and then we'll have a 10-minute discussion, and then open it up for questions. So it's a great pleasure to be here. This is a paper, Artificial Intelligence, Economics, and Industrial Organization. I sometimes call it the AIEIU paper. So it's kind of like Old MacDonald had a farm, AIEIO. So organization here, I'm going to talk about a bit about machine learning, a bit about artificial intelligence and online competition, a little bit about startups, a little bit about RD. So there's something for everyone in this talk. This is the triangle that's drawn the first day in the first class of information science. At the bottom we have data, and as you collect data and organize it, lend insight to it, you can turn the data into information. As you take the information and you analyze it, you can turn the information into knowledge, and then, of course, you can turn the knowledge into action. So there's a lot of debate now about the data economy, maybe the information economy, the knowledge economy. They're all part of the same process. None can stand on its own, really. And let me turn to machine learning and AI. Machine learning has been around for a long time, as is AI. But in the last 5 years, there's been a very fruitful combination of artificial intelligence and machine learning. And these AI techniques have been adapted to learning things that 5 years ago, 6 years ago, we thought were really impossible. But there's been huge breakthroughs in terms of image recognition, in terms of voice recognition, in terms of automatic translation. And it's a remarkable period for artificial intelligence and machine learning these days, because so many techniques have emerged now that just a few years ago were thought to be impossible. And why have we seen this renaissance? Well, we've had better algorithms, we've had better hardware, we have better data, and most importantly, we've had better expertise, because people have learned to apply these techniques to problems that were not possible before. The hardware and software, they're pretty easy to acquire, because you can go to cloud computing at Google or Amazon or Microsoft, and you have at your disposal a lot of special purpose hardware, a lot of special purpose algorithms that allow you to apply the machine learning. Data is often easy to acquire. Data nowadays is generated as a side product of other activities. And the challenge is to take that data, remember the base of the pyramid, and turn that data into information by using the tools that I just described. And these days, the scarcest factor by far is expertise. You're seeing salaries being bid up and people moving from place to place because the necessary experience and expertise is scarce, but our universities, our schools around the world are turning out students who can use these techniques, and I think soon that barrier of expertise will fall. There's a nice little company called Kaggle. Kaggle sponsors competitions in machine learning. So if you have expertise but no data, and he has data but no expertise, well, you'd like to get these parties together. And what Kaggle does is it will work with a company to extract a set of data for training and for testing and for validation, and then offer prizes for the parties that can best satisfy this challenge. So the money can mount up quite a bit. On Zillow, for example, which is an online real estate site, they use a machine learning system to estimate the value of a house. This is very important to them as an attraction to potential home buyers and sellers. And so they're willing to pay, $1.2 million to whichever group is able to come up with a significant improvement on the technique that they're currently using. And I've listed a number of these: traffic to Wikipedia, personalized medicine, taxi trip duration, product search relevance, et cetera, et cetera. You can go to Kaggle and browse through this list. They have about 220 competitions since they started, and get a good idea of practical questions, practical answers, how much companies are really willing to pay to get these prediction problems solved. So it's a nice illustration of real world, real problems with real money and real solutions behind them. And this is just a little chart. The people who are using Kaggle, who are competing in those competitions, are in fact from all over the world. A lot from North America, of course, a lot from Asia, and we're seeing more and more from Europe entering into these competitions, because every class of machine learning, they'll have a little Kaggle competition as a real-world example for the students. So it's a very nice way to get a picture of what's going on in this particular area. Okay, so remember I showed you that pyramid, the data pyramid. Let's talk a little bit about data. So people say data is the new oil. Well, my response is they have one thing in common: to be useful, they have to be refined. A barrel of oil isn't worth much. You turn it into gasoline or kerosene or hydrocarbons, then it's worth something. And it's the same thing with data. Raw data is worth very, very little. It's not worthwhile until it's really distilled into the information and knowledge that I described earlier. Now, in economics, unlike oil, data is not rival. You may have a barrel of oil, or I may have the barrel of oil, but it's excludable. It's rival. If I have it, you don't have it. But with data, it's quite different. We can easily have access to the same data at the same time. Just like all these Kaggle competitions, there could be hundreds or even thousands of groups around the world that are analyzing the same data. So I think it's a mistake to discuss data ownership because it's too narrow a concept. It makes sense to talk about ownership of a barrel of oil, but when you have data and used by multiple parties, really you want to talk about rights, access, licensing, regulation, contracts, permissions, all sorts of contractual ways to share access to data. It could be an exclusive, just like the barrel of oil could be exclusively owned, or it could be a license where you could manage it for a specific amount of time. Many, many things are possible. So you would think much more broadly about this concept of ownership. It's really a question of contractual arrangements, and usually pluralism, multiple access to data is important because it allows for a diversity of viewpoints, and in many cases it allows for a significant improvement in terms of utilizing that data. Some party may come up with new ideas for how to use a particular set of data, and that's all to the good. Data portability, well, we have something called Google Takeout. So we've provided this for, 7 or 8 years at least. You can go to Google just with a few simple keystrokes, download all of the photos you put on Google, or all of the emails, or all of the search history, et cetera, et cetera. And so the data has become very portable. Interesting thing is, even though we offer takeout, there aren't so many take-ins, that it's rare to find someone who says, yes, yes, give me your data, give me your data. I want to use it for this new purpose. So take-out is easy, take-in is a little bit harder. Where does the data come from? I've got a long list here. I have to look at it myself. Byproduct of operations, that's by far the most common form. Everybody's spent millions of dollars building data warehouses. They're acquiring data about operations, about consumer behavior, about marketing, all sorts of different things. And the challenge is, how can you use that data effectively? Of course, there are huge amounts of free data available on the web. You can build a web scraper yourself, or you can use Common Crawl, which is a free access to the entire web, literally petabytes of data that can be accessed. You can offer a service. Several years ago, we realized that we needed to acquire expertise in voice recognition because mobile phones were emerging as a way of accessing Google services. We had no expertise, we had no data, so what did? We hired the best people in the world, and they said, let's build a mechanism to acquire data. We set up a system called Goog 411, which was an information service. You could dial Goog 411 and say, I want the phone number of Joe's Pizza on University Avenue in Palo Alto. And it would say, do you mean John's Pizza? No, I mean Joe's Pizza. And so people trained this system by using this service efficiently. It learned how to recognize voices, it learned how to recognize accents, it learned how to recognize all of these different things in this very limited domain of directory information, but that was enough to get started. And now I think we have one of the best voice recognition systems in the world. You can share data, buy data, data from governments and NGOs, cloud providers. So you look at Microsoft, Google, Amazon. They're not only providing you with the algorithms and with the hardware, but they're also more and more providing you with the data. So it could be census data, it could be traffic data, it could be weather data. All sorts of data repositories are available via the cloud services because it makes a better product for the users. They can hit the ground running and they can do the analysis they want by merging their own data or their own analytic techniques with the public data available on the cloud. So here's some example of data training sets. Google released 9.5 million images labeled with their contents to the public at large, to the Open Image Project. Video understanding, 8 million labeled YouTube videos. So right now, image recognition is a solved problem. You can do very good image recognition using the tools that I alluded to a few minutes ago, but identifying video content is still rather difficult. You can see a group of people and ask, are they fighting, are they dancing, are they exercising, are they marching, what are they doing? The machine systems are not sufficiently trained in understanding activity, video activity. But I think this will become a solved problem in just a few years, and this 8 million labeled YouTube videos will facilitate that. Voice data, crawl data set, I mentioned that. Click prediction, OpenStreetMap, the Kaggle data sets, 6,784 data sets available. European Parliament proceedings. Now, one of the really good things the European Parliament has done is produce these multiple translations of all of the activity and speeches and bills that go on, and that data has been really invaluable in terms of producing automated translation of machine learning systems. Canada has also been very helpful in this regard, since everything is done in French and English, or you could look at Belgium, on and on and on. These translation documents are extremely useful for this kind of analysis. Let's see, how important is data? So I said it forms the base of the pyramid, but then the question is, there are other issues, the expertise, the hardware, the software, and so on. So how important is data? Well, here's the ImageNet challenge, where they had 20 million labeled videos, and each year for the last, how many years is that, 6 or 7 years, they've chosen 1.2 million images for training your machine learning system, and then 150,000 images for testing, and everybody who did image recognition would compete in this ImageNet challenge because they wanted to show why their system was better than the other guys. Interesting thing about this is they kept the size of the training set fixed because they were interested in the algorithms and the hardware improvements. And here's what the error rate looks like. Back in 2016, for the first time, they surpassed humans in terms of image recognition, and it just keeps improving since then. And remember, this was a fixed set of data. So having more data was never an issue here. It was really coming up with clever algorithms and better hardware, and of course, the accumulation of expertise. So data is important, nobody's going to deny that, but it's not the only thing that matters. And this is a picture of a ImageNet competition on a subset of data, namely recognizing dog breeds. Okay, so there are about 200 different breeds of dogs, and now you can take a picture of a dog using Google Photos, and it'll tell you what breed it is. It's pretty magical. 120 different breeds of dogs, 20,000 images, and they looked at the number of training images and how the accuracy improved as they increased the number of images. Obviously, it gets more accurate as it has more data, but there's diminishing returns, just like any other factor of production. And here's a few examples. If you go to cloud.google.com/vision, you see this empty box, and you can drop a picture into that box, and the machine will tell you everything it recognizes in that picture. So here's an example. This is a cat, our cat, in fact, and guess what? It recognized it, 99% sure it's a cat. It's a small to medium-sized cat. It's a cat-like mammal. But here's ragdoll. Well, that's the breed of cat. So not only did it recognize it was a cat, but it recognized the kind of cat it was. And it does the same thing for dogs and horses and all sorts of other things of that sort. Here's a picture of Wikipedia that says that's a ragdoll cat, and this is a picture of our ragdoll cat. So you see it did a pretty good job of recognizing that particular breed, which is quite remarkable. Now you can do it with plants, all sorts of things. You photograph a plant and it'll tell you what the plant is and how much water it needs, how much sunshine it needs, all of those things. You don't have to memorize these long lists of cats or dogs or plants. Your mobile phone will tell it for you. Now, what happens in terms of providing all of these great services that I just described? Well, it's a very, very competitive market. For example, here on the left, gosh, what do I have? I have the Google pricing for image recognition. And here on the right, I have the Amazon pricing for image recognition. And it's basically 1/10 of a cent per image. So you can feed in thousands of images. It will get this labeling I just showed you. And it does that for $10, a very, very low cost, 1/10 of a cent per image. So this process, which took, let's say, many years to develop and a lot of expertise, a lot of hardware, a lot of software, a lot of training went into it, but now it's been essentially commoditized. So anybody has access to this at a very, very low cost. And in fact, this is not unusual. You'll see the same sort of thing happen with other kinds of machine learning because of the competition in the industry I just described. So there's competition in pricing. As soon as Amazon changes the price, Google follows, or Google changes the price, Amazon follows. The standard services that are offered, everybody's offering images, transcriptions, voice, translations. Again, if you go to the cloud.google.com/translation, you can drop in a text from some other language and it will translate it for you. You could do similar things with voice transcripts and so on. On the cloud computing services, not only are you getting the data sets I described, the algorithms I described, you also get some training, assistance, consulting, etc. So it's made it far, far easier to begin a business in this area because you've got all of these services available just from the beginning, from the first day. And in fact, I think this general theme of online competition, which has become a very contentious issue in Europe in particular, if you look at this chart, you can see the competition going on between Amazon, Apple, Google, Facebook, and Microsoft in advertising, autonomous vehicles, browsers, digital assistants, ebooks, etc. So all of these services are now available at a very low price, often zero, at a very high quality compared to what we had available 5 years ago, and they're continually innovating and improving and offering the services. So the reason that you see so many low-cost, highly available, technological advanced services is because of competition, because all of these companies are competing with each other to provide those services to potential users. This is a picture of R&D spend, which is pretty interesting. According to this chart, Amazon is the leader in global R&D spend, with Google close behind. The red dots are the technology companies. The green are autos. And you wouldn't have seen this a few years ago. Why are all the auto companies investing so heavily in R&D? Well, of course, it's autonomous vehicles, a huge opportunity, and let's say an opportunity and a threat at the same time, because if your competition moves ahead and you fall behind, it's going to be very problematic. But of course, for users, the advances in these areas are really staggering, where we're seeing lots of spend on R&D, but lots of outcomes that are, again, something that was inconceivable just a decade ago. People would find it very hard to believe that you can have fully autonomous vehicles, but now it's definitely a reality. And one example of this competition I referred to, this is a competition in home assistance where you have smart speakers like the Google Home Mini or the Amazon Echo. This first came out from Amazon. Within 9 months, Google announced its home speaker. Now we're seeing a very intense competition going on in that area, with prices being computed down and the number of services rising very dramatically. So from our perspective, from the company side, we're seeing huge amounts of competition going on in pretty much every area, from cloud computing to smart speakers to home video. And the venture capital funding is robust. This is a picture of what venture capital funding looks like in the US and in Europe over the last decade. The peak, of course, was back in 2000, the dot-com boom, as they say. But now we're seeing expenditures on VCs and venture capital investments that are the highest we've ever seen since that 2000 period. So we've got robust activity going on the commercial venture side as well. And in fact, that's partly because it's so easy to start a firm, because so many business processes can now be outsourced. So this is not entirely serious. How to start a startup? Well, you can fund your project with Kickstarter, you can hire employees using LinkedIn, you can use cloud computing from any of the providers I mentioned. Open source software is widely available, et cetera, et cetera, et cetera. So all of these services and capabilities are now available. It's like a construction kit for starting a business. You can handle HR here, legal here, R&D here, and start your business going really from scratch in a much more efficient way than was possible 5 or 10 years ago. And that's the talk. AI is here to stay. Hardware, software, data, lots of practical applications, very intense online competition, and a lot of entry going on in this area. So we really live, I think, in a golden time in terms of innovation in the digital context. And, well, I'm interested to hear your opinions on this. So let's turn to the conversation. Thank you.
So, Professor Varian, thank you very much indeed for the very timely and interesting comments. Now, one thing that crossed my mind as you were talking about the many applications of artificial intelligence and, of course, big data is we all realize there are huge, tremendous potential. In your view, are there any limits to AI, to its usage and applicability? And of course, I'm not talking necessarily technological limits, because with computing power and storage capacity increasing, this is no longer a concern. Perhaps not even expertise limits, because we're getting better and better at it. I'm thinking more in terms of behaviors, psychology.
Well, I do think there are limits. We've had this tremendous breakthrough, so that's made people very optimistic about these fields of image recognition, voice recognition, translation. Of course, there's a great deal of interest in seeing how far these can be pushed and how far can they go. I come from the machine learning background, so the AI techniques of using neural nets and deep learning and so on are novel to me, but it's amazing to watch what people have been able to do. And there's a lot of interest these days in what's called transfer learning. I mentioned it on one of the slides, but I didn't talk about it. It's how you can use what you've learned in this area to carry over to some adjacent area. So you've learned how to recognize all these breeds of cats. Can that help you recognize breeds of dogs or horses or monkeys or whatever? And it turns out with humans we do that. We extrapolate our learning, and now machines are beginning to do that as well. So at this point I would say I'm sure there are limits, but we just don't know where they are. And that's why there's so much excitement surrounding this area.
And do you ever feel that there might be certain resistance from the point of view of the end user to these techniques?
Yes, I would say the businesses, you said? And
The end user.
the end user.
So.
Yes, well, of course, the end users, I think, will find a lot of these services and these capabilities very, very helpful. I like to say, if you want to see what the future looks like, look at what rich people have today. In 5 years or 10 years, that will be available to everyone. So now rich people have human assistants who help them organize and plan their lives. But within a few years, everybody will have a digital assistant that will provide the same functionality.
That will make our lives certainly easier.
Won't it?
Now, speaking as a statistician, of course, we're talking here with big data, primarily pattern recognition and prediction, a lot of that. Now, of course, from the point of view of classical inference, the holy grail is causality.
Right.
How do you think of causality in the context of big data and machine learning?
Mm-hmm. Well, of course, if you can, as you indicated, if you can design an experiment and run an experiment, that's going to be the best way to understand causality. And at Google, we have built platforms for doing this kind of experimentation, and not only for ourselves, but also making those available to our users. So I think we'll see a lot of exciting activity there in terms of using these systems to detect causality for everyone. I mean, just as you've democratized this so that lots and lots of different parties can use these systems to understand the causal connections in marketing or production. But there are also some techniques that you can use that are using quasi-causal data. That is, they're looking at situations where you're trying to infer causality in a way that allows you to do this without using a classical randomized control problem. So things like difference in differences, or regression discontinuity design, or instrumental variables, or other things of this sort that are finding their way into machine learning. Mm-hmm. Not as good, but better than nothing. So we think we can learn a lot from those statistical techniques applied in this context.
Yeah. Now, you have talked a bit about the competition in the online marketplace, and of course there's a large academic literature looking at the link between competition levels and innovation outcomes. At what level on that curve do you find that we are now?
Well, I think what's interesting about online competition as compared to offline competition is how easy it is to switch to alternative providers. So if you don't like Google's results, you can type a few letters and go to Yelp or go to Bing or go to any other kind of search services. So using alternative providers is far, far easier online than in any offline business. So that's why it's so competitive, and that's why we're seeing so much online innovation and technological improvement because of that competition.
And you expect that this is going to continue?
Say again?
You expect this is going to continue?
Yeah, I think so, partly because the entry costs have gotten down so low. So somebody with a new idea can often get funding and can get the cloud computing environment and apply these state-of-the-art algorithms. So there's no shortage of entry in this area at this point.
As, of course, we all know, very soon in Europe we're going to have the new data protection regulations coming into effect. What impact do you expect this to have on the general online activity and the way in which the online businesses?
So if you look at the so-called industry giants, you look at the Googles and the Facebooks and Microsoft and Amazon, they've all spent 18 months or 24 months working to be compliant with GDPR requests that might occur. So we feel pretty confident that when the magic day rolls around, 10 days from now, or pretty soon, that we'll be in compliance. But I think going forward, it will be more difficult for small companies to take on this extra obligation to be able to produce the reports and the user requests that come in. So I do have some worries about whether this vibrant competitive ecosystem will continue to thrive because you've added some more friction. I think that's undeniable that there's a bit more friction there, and just how the industry as a whole would deal with that, it remains to be seen.
Probably slowing down the pace, but still keeping the general.
Perhaps, yeah, we hope not, but it's possible.
Right.
Yeah.
Well, I would like to turn the floor over to the audience and take a couple of questions.
Mr. Varian, I'd like to know, you said that artificial intelligence consists on expertise and data, but I think the real and realistic data will only come from the real professionals working in a certain area, working in a certain job, having the everyday experience and having the psychological connection to the consumers. And I think those professionals won't be very interested in giving data to some enterprises who are willing to substitute those professionals by themselves. So how are you going to get this data from the professionals?
Right. Well, there are lots of examples out there. You may have seen the famous cucumber sorting example. There was a student in Japan who worked on machine learning. He went home to visit his parents, who had a small farm for cucumbers, and realized, well, here was a place he could apply his knowledge. And indeed, he was able to set up a machine learning system that made the family farm much more productive. And all of these Kaggle data sets that I showed you, this 220 data sets, are in fact available for researchers to apply their skills to. And all of these 9.5 million still images and 8 million moving videos from YouTube, they're available. So I guess my experience is that typically it's possible to acquire the data you need. And if you're an ongoing organization, the data is typically available as a byproduct of actual operations. So I understand that particularly in Europe, people were talking about the data economy and data monopolization or data competition, whatever. But in practice, I haven't really seen it being a problem. That usually people have the data. The challenge is finding the expertise to extract the value from that data. So Mike?
It's fine. As far as I know, machine learning allows one to accurately determine who. I mean, the machine learning allows you to correctly gauge who your agent is, and there is basically no asymmetric information. And in this regard, do you believe that the information economics is still relevant?
Well, yes, I believe economics is still relevant.
I'm talking about the hidden action, hidden information.
Hidden action, hidden information. Well, it is interesting because one of the possibilities that computers offer us is they offer better monitoring and compliance. If you agree, you and I make a contract that you will do some service and I will pay you to do that service, there's always the question of how do we verify whether you're really providing the service at the agreed upon level, and having computers available to monitor those performance in contracts, that's actually quite helpful. So that's kind of abstract. Let me give you a very concrete example. It used to be that the contract between an advertiser and a publisher was pretty simple. I'll put your ad up in my publication, and maybe people will see it, and maybe they'll come to your store. That was what the old world looked like in advertising. Well, now, online, is I put your ad up on my publication, and only if people come to the store do you have to pay me. That is, just seeing the ad isn't enough. You're only going to pay for that ad if there's a click and a visitor that is associated with it. So you've got a much, much better measure of performance in that contract than you had prior to the online world being a primary source of advertising now. So it's a big change, and of course we've seen this explosion in advertising online because of the fact that it is so easy to monitor. Questions? Oh, here we go.
In your presentation, you went to great lengths to convince us that there's lots of competition, and just now you did so as well. So I'm wondering, under what circumstances could you see yourself arguing in favor of breaking up your Google or any of your competitors?
Yeah.
Thanks.
Well, I've gone to great lengths, but let me go another length or two before I address that question. If you look at online search, general purpose search, my argument is it's a really tough business because you can only sell 6% of what you produce. Because if you look at clicks, 94% of clicks are on organic results and only about 6% of clicks are on ads, but ads are where all the money is. So in fact, there's really intense competition on commercial searches, right? Commercial searches. If you search for travel, there are many travel providers, Orbitz, Expedia, Trip Planner, et cetera, et cetera. If you look at shopping, there's Amazon, there's eBay, there's many comparative shopping services, Google Shopping, and so on. If you look at insurance, or you look at automotive, or you look at any of these areas where the query has a commercial value, there's typically a large number of competitors. And if you think about it, firms that enter into this area are focusing on the commercial side of things because that's where the money is. So actually, even though Google has, I would say, obviously a strong position in terms of general purpose search, it's really that 6% of the searches that are commercial that are really contested. And so that's where all the competition is on that relatively small segment. Way in the back there.
As you're probably all aware, there's been a lot of political controversy around some of the services that have become available because of the internet and these huge platforms. So I'm wondering what your analysis is of how soon these tools that you've just shown us will be able to filter out some of the content that we might not like to see. Now, whether that's competition related, people uploading the most recent football video from a game that's just finished, or whether it's related to political events, it would be really interesting to hear how soon you think that will work, because at the moment, as far as I know, Facebook is still employing humans to actually filter out stuff.
Well, on YouTube, we're working very actively in that area, and a substantial number of YouTube videos are filtered using machine learning techniques, and often at this point reviewed by humans for the final decision. But this technology is getting better and better. Part of the issue is you might have exactly the same image, and in one case, the voiceover could be very positive, and in the other case, the voiceover could be very negative. So you see some battlefield situation. Is this a movie? Is this a documentary? Is this a news? Is this an ISIS recruitment film? In lots of cases, there's still ambiguity that you can't resolve until you look not only at the image itself, but also what people are saying about the image. Now, this can be solved. This is not an impossible problem by any means, but it's just the affect can be quite different given almost the same content. So that's why it's challenging to really analyze these completely by machine. We think that it has to be people plus machines to be really effective.
I'd like to return to this question of whether there are limits, and I'm actually interested in the technical limits. Is there any particular area where you say this is going to be really hard to crack and we'll never get it to be done? And kind of building on this, would the limit not be the very expertise that you're saying they're currently lacking? So the people who develop artificial intelligence, are they going to be replaced by artificial intelligence at some point?
Well, there are several challenges in this area. One is what's called adversarial AI. So you can deliberately design images to fool some of these AI systems. So just as human beings are subject to optical illusions, computers can be subject to optical illusions, but they're completely different optical illusions. So what fools a computer wouldn't fool a person, but what fools a person, that wouldn't fool a computer. So there's this whole issue of how do we deal with adversarial artificial intelligence. And another challenge is the so-called right to an explanation. In some of these AI systems, they make decisions, or they can come up with a good predictive model, and we don't really understand how they came up with that model. So an example of this is there were a number of medical images that were examining the retina in the eye and using this as an indicator of health, and those were quite successful in doing that. And along the way, they discovered that the images of the eye could also be used to identify gender. So it was 85% accurate in identifying whether it was a man or a woman, and the medical literature had never noticed this before. And in fact, just a human looking at the images could not understand why this was classified as from a male and why as a female. Well, after a few weeks of work, they were able to understand the difference, but it isn't something that's immediately obvious in many cases. And there are a lot of requests or a lot of proposals that there should be the ability to explain the decisions made by these AIs. Again, I think that's a solvable problem, but it's just we aren't there yet. That's a challenge that we have to face in the coming months and years. There's somebody back there.
So I got a question about the role of government in the data economy, and basically it's a twofold question. The first one is in terms of regulation. I think if I interpret you correctly, you're slightly skeptical or at least hesitant when it comes to the regulation here in Europe as in terms of the complexity it will introduce. But do you think something like this might happen in the States? And the second question is in terms of resources. I think you're absolutely right. There's a ton of resources online already, but where do you see the role of the public sector or the government to provide more data or resources to sort of accelerate the data economy?
Well, obviously there'll be regulation, of course, both in Europe and in the US. And of course, let's not forget about China, where the regulatory environment might be quite different. I think that there are many attractive opportunities in medical studies and health that will benefit from machine learning. These areas are both very, very important to people, and at the same time, they're often somewhat sensitive in terms of privacy issues. So in my view, I think we should be very careful about constructing legislation in these areas because the potential benefits are so great. So I'm not opposed to regulation. I just think that regulation has to be applied with a great deal of care so we understand what the harm is, why the legislation or the regulation can mitigate that harm before we run out and start passing laws. We'll see. We'll see how that works out. By the way, in the US, there's now a referendum on the California ballot that is very similar in spirit to the GDPR. So clearly these kinds of regulations will be arising.
So we have time for maybe one more question.
There we go.
Well, you just raised the issue of China, and I realized that in the slides you presented, none of the Chinese internet giants are there. And of course that makes sense because the markets are, as of now, fairly separated. But I would like to know what your opinion, or maybe even Google's view on the whole issue of Chinese internet giants are. And yeah, maybe just some insights from your perspective.
Well, I will only state my own opinion. I'm not going to try to guess what Google's opinion is in this area. But of course, doing business in China is very different than business in the rest of the world. It's very highly entrepreneurial. There's this very important role between the private enterprise and state enterprises. And I think it's going to be difficult to export that Chinese model to other countries in the world. So it's quite impressive to see the kinds of things that are happening there, how quickly things are moving, but will those be able to become global companies? I think there's considerable skepticism on that particular issue. So maybe that's a good place to end.
Thank you very much for joining us today, and thank you, Professor Varian, for this.
Thank you.